it. Okay, so
Yeah.
as I was telling you in the beginning, like if it happens that my internet disconnect, you're not going to be leaving the meeting because anybody can join at any time, and I don't have to allow anyone in the meeting. So I mean, you have the liberty to come in and out as you will. Okay, so as I was telling you, okay, so the first thing that I want to show you here is your course outline, because that's a very important aspect of knowing where is it that you are supposed to be and what is it that you are supposed to be learning. So right here, when we come to the course outline, hopefully you still can see that. Okay, here. Now you can see the course outline on the screen.
Hmm.
I just want to touch on a couple stuff before we move on. Okay, so this is of course electrical fundamentals, and what is it that you are going to be learning in electrical fundamentals? Okay, so this is going to be based on learning about the electron theory. There's going to be like a bunch of terminology that we have to master that are called voltage, current, resistance, and then we are going to get acquainted with Ohm's law and do a lot of calculations in Kirchhoff law, as you can see that it says here. Okay. And in spite of that, also we are going to get into a bunch of different measurements, um, including like power, power and also work. Also, we are going to be able to do like voltage drop. Like you are going to do voltage drop in electrical code, but also you are going to be doing voltage drop in all cores because we view it from a different point of view. And then you are going to be able to see where that terminology that you have in code, which is called circular mills, comes from. Okay. So here on the course outcomes, those are the stuff that we are expected to know at the end of this course. Okay, so you're at the end of this course, there's 7 specific outcomes that we want you to be able to master, like describing the electron flow theory. You got to know about the difference between the electron flow theory and the conventional flow theory. Also, to be able to define voltage, current, resistance, and also power and energy, and be able to use all these different concepts and all these different terminologies, know what they are, and know how to apply them in formulas in order to solve problems. You are going to find out that working in the electrical field, knowing what is called Ohm's law, which is the relationship between voltage, current, and resistance, is very, very important, because whenever you are doing troubleshooting, you will need to remember how to use Ohm's law. Whenever you are troubleshooting, to know if a circuit is, let's say, like if a circuit breaker is tripping because of an overload, then you are going to have to measure resistance, like test the continuity in the circuit and measure the resistance. And after you measure resistance, you are going to take your calculator and check to see what is the amount of current that should be flowing in the circuit. Okay, so you're going to be able to play with this. And once you can master all these formulas, when it comes to troubleshooting in the field, that's going to make your life easier. Also, this is something very short, which is on the LMARS. I'll just highlighted that on the screen, describing the effects of electricity on the human body. We are just going to touch based on that. And the reason why we do that is because we want you to be able to see why is it that rule number 1, whenever we are going to troubleshoot anything, is disconnect. Okay, shut down the power, switch down the power, because it only takes 100 milliamps to send your heart into a state of fibrillation, which means that your heart doesn't have the energy to pump blood through your body. And unless you use the defibrillator, then you are pretty much you passed away. Okay. And it only takes 100 milliamps. Like a telephone like this, it takes way more than that, to operate and to work. Also, we're going to be getting like into all the other stuff like electromotive force, which is not more than voltage. And then one of the important components, the heaviest part of this course, is based on being able to learn and solve series, parallel, and combination DC circuits, okay? If we are solving series, parallel, and combination circuits using resistors, it doesn't really matter if we apply DC, which is direct current, or if we apply AC, which is alternating current. However, when you get into level 2, it's very important that you can master, that you can know the difference between a series, a parallel, and a combination circuit, and be able to apply what is called Ohm's law and Kirchhoff law in order to be able to solve those circuits. Okay, like if you can do it now in this level, then it's going to be a breeze to be able to do it in level 2 when you do AC, alternating current fundamentals. Okay. Something that, because of the way that we are doing this course, which is online, as we know, and this is what is called synchronous learning right now. This course actually takes 8 hours a week when we are in the college. So far, I am very glad that this time around I was given 3 hours to be able to do what is called synchronous learning, which is that we connect online for 3 hours, while in the college we are connecting in classroom for 8 hours a week. So that being said, it means that there's going to be a lot of responsibility. The burden of responsibility is going to be placed upon you. Okay, so I want you please to keep that very clear in your conscience. The burden and responsibility at this point in time is upon you. I'm going to do my best from my end to give you all the information that I have to give you. But at the end of the day, you have to be able to, you need to have the discipline to get online and to complete all the different tasks every single week that you will be given. If you don't do that, then there's not going to be much that I can help you with. Okay. So this is like a two-way road, a two-way commitment. I'm going to be doing my part. But most of my part is going to be pretty much like 30% of the course. Joe's part is going to be the 100% of the course. Okay. That being said, I don't want you to feel like frustrated about it. Anyways, everyone is going through the same process. All the students in university are going through the same process. Colleges, everyone is going through the same process where we have to become up to some point an autodidact. Okay, which means a person that is learning in isolation, a person that is learning by himself or herself. Okay, so as I said, we have the great privilege that we'll be together for 3 hours. But the rest of the time, you need to have the discipline to focus and to do the work that you are going to encounter through this course. And once you do your work, you are going to have questions. And when you have questions, you are going to ask those questions, because that's one of the important parts of this, that as you are doing your work, you are going to have questions. And then we are going to be able to answer those questions within this online community. And these answers mostly are going to be coming from your classmates, but on this, and also they are going to be coming from me. Okay, so it's going to be coming from within the community. So I'm going to assist you as much as I can, but I'm going to try to guide you without giving you everything, because that's what is going to be leading you to learning. I'm looking for learning here, not just memorization. If you try to memorize the course content, it's going to be forgotten when you get to level 2. But if you are studying and trying to master the course content, then it's going to be more than just a memorization game, and you'll be able to be successful going forward into level 2. So, as I said, like I already mentioned, like the first basic course outcomes. Okay, so there's a few like essential employability skills. So I'm just going to give you the time. I mean, like not now, but you are going to have the time to please go ahead and check the complete course outcome. Okay. So in today's class, we are going to be getting into a few mathematical calculations. You can see that right here. Okay, one of the essential employability skills that you are going to be gaining from this course is to be able to execute mathematical operations accurately. In order to do that, because I know that some of you has been out of school for a while, in order to do that, we are going to, during the first week, concentrate on 2 themes. We are going to concentrate on getting back those mathematical skills, number 1, and number 2, we are going to get started with the first part of the unit outcomes that we have for this course. Those are like the basic electron flow theory, okay, which is like 0.1.1. And then we are going to be concentrating on this topic as well throughout this week, which is to demonstrate an understanding of the electron theory. And that's what's going to be leading you into knowing the difference between the electron and the conventional flow theory. So I'm seeing that there's a lot of chat, okay, like around, like is anybody having any issues? I know that somebody was having some issues with audio. Is that solved now? Okay, perfect. That's good. That's good to know. And anyways, please, guys, take the time. Take the time to go through all the unit outcomes, because this is how you will know what is it that you are supposed to learn. Like if we are covering something in this course and you wonder, like, what's the point of covering this? Then you can always fall back into the course outcome and see, okay, so this is part of the stuff that we are supposed to be learning. Okay, so when it comes to this part here, analyze and calculate voltage, current, and the power characteristic in a 2-wire and 3-wire distribution system for balanced and unbalanced and faulted conditions. I hope that you have a small book that accompany Delmars that you were given, or I mean, whenever you bought your book package, were you able to get that small green book that has that information? You can type now, yes, not, or you can just mute yourself and say something. Yes, perfect.
Yeah, I think mine's coming. I ordered my books yesterday, so.
Oh, okay, perfect. So you all going to be getting them very soon.
I have it. Yep.
Okay, perfect. So we're not going to cover this topic for now. That's going to be like week 5 or 6. So for now, we are good up to this point.
Is that a book from Conestoga or from the Union, or from like the Union Hall?
Oh, okay, perfect. Yeah, that's good. So you should.
No, is that a book from Conestoga or from the Union Hall?
Oh, no. It's just a book. Like, I mean, what happened is that the students always get their book at the bookstore. But in this case, like if you are a union, you are going to be getting all your books from the Union Hall, but they are the same books.
Perfect. Just making sure it wasn't some other book.
Yeah. No, that's just a small booklet, you know. I'll show you that like next week, so you don't have to worry about it. It's just that I want to make sure that you have that right from the beginning. Okay, anyways, so your test, you are going to have like 4 tests. That's going to be the type of evaluation that we are going to be doing. But what I do for this course is that your test is going to be open for the whole day to give you the flexibility of being able to go online and do the test, whenever you can. So let me just walk you pretty quickly. Okay, so I'm going to cancel this screen here. So we can go to, okay, so going back into Joel course, when we go into the course content, let's get into that tab. In that tab, you have some information, like, for example, your instructional plan. You got like something which is called the course information. Please take the time and read it, okay? And right after the course information, then we have the instructional plan that I'm hoping as well that you take the time and read it. This is just to give you an idea on what is it that we are going to cover throughout this course. As you were seeing in the course outline, you are going to have 4 different tests. Okay, so you are going to have 4 tests, beginning with test number 1, which is going to be worth only 15%, 15% of your final mark. And then the second test, which is going to be based on series and parallel circuits, is going to have a weight of 25% of your final. And then the third test is going to have a weight of 20 and the final 40%. Everything add up to 100%. Now, the way we do this test is that every 2 weeks, okay, so let's go into the course schedule. On the first week, we are to cover from January 25th to January 29th, scientific notation, metric prefixes, and basic equations. Also, we are going to cover the effects of electricity on the human body. And also, like, we are going to get into the basic electron theory, okay? And this is basically what we have to cover the first week. So what we are going to cover today, though, we are going to be getting into all this mathematical stuff. And then this is something that I'm going to be asking you just to go to the ELMARS and read on your own, the effects of electricity on the human body. And if you have any comments or if you have any questions, then you are completely open to send an email or just to go to a chat, like you just to go on Iconestoga. I'm going to show you that later on the chat and just post a question or post a comment. Also, then you're going to be expected to go to check the PowerPoint about the electron theory. And what I'm going to do myself is that I'm going to be recording and posting an asynchronous, like a video, okay, that you have to watch on your own, in your own time, and you have to watch on your own about the PowerPoint of the electron flow theory, okay? And these videos, usually I'm going to try to keep them as short as possible, no more than 10 to 15 minutes. And that way you can watch them at your own convenience, okay, in your own time. Then during week 2, which is going to be February from the 1st to the 5th, which is week 2, we are going to cover in class some questions and answers from whatever, ideas that might not be clear from week 1. And then we are going to be getting into the different ways of producing electricity, and we are going to be getting into performing calculations. So that's going to be the big part of week 2 lesson, performing calculation using Ohm's law. And you are going to be required and expected to do a lot of calculations, because that's how we tend to master math by doing calculations, okay? So also during the first week, right here, we encountered already what is the first test. So the first test is going to be Friday the 5th, and it's going to be based here. You will always have the topics upon which the test will be based. In this instance, it's going to be based on the math review, the atom theory, and quantities and Ohm's law. And the test is going to be 15% of your final mark, and it will be open from 6 in the morning all the way down to 11:30 at night on Friday 5th, on Friday, February 5th, which is pretty much next Friday of this year. And your results, once you submit your test, your results will not be available right away, but you will be able to see your results before class. For the following Monday, like in that case would be like on February 8th, early in the morning, you will be able to see your results already. Because I like to make sure that I go through the whole test, through everyone's test, before I give you the score that you were able to get on any specific test. And that's going to be the dynamic that we are going to follow in these scores. Also, I want you please to take the time and just make sure, like if you are confused during any time during this course, let's say in week 3, you say, okay, it's week 3. So what is it that I'm supposed to be doing? Number one, you are going to be able to see that in that week, indeed, you have the topics that we are supposed to be learning. So like, let's say week 3 tells you that you are supposed to be in Unit 6, which is series circuits, and Unit 7, which is parallel circuits. And when it says unit, what book are we talking about? Well, as per our course outline, we are talking about Delmars, the standard textbook of electricity. I am going to supplement the course also with a couple chapters from another book, which is called DC Fundamentals, but I'm going to make those chapters available on Conestoga. Okay, so when the time comes that we have to use, that we have to learn from DC Fundamentals, though that chapter, which is pretty much like power and energy, that will be available to you on Conestoga as well. Any questions so far about the instructional plan?
It's not about the instructional plan, but there were some people further up in the chat that were asking questions about the book, as they were asking if it matters if the author is different.
Which book?
I'm not too sure. I just know that there was a couple people that put that in the chat.
Thank you for letting me know. So because I'm talking, like, it is difficult. Yeah, the author is Antonio Fasari. Antonio Fasari is a professor from Mohawk College, and he's the author of that small book, of the small green book. And the book that we are using for our class, it's going to be that book from Antonio Fasari, which is a supplement to Delmars, but the book we are using is called Delmars.
One person wrote in the chat 3-wire distribution systems.
Yeah. But the 3-wire is listen, the actual book, yeah, it's a small green book. Yeah. You say a small green book, and it is the book that, everybody has to be using the same book. Okay, so, and it's called like that, 3-wire distribution system, and it's a very, very small book, small green book. It's not small, it's very thin. It doesn't have any pages. Okay, so can we keep moving? So when we get back into here, okay, so we already saw the instructional plan, your login, so you already know where to find your meeting link. So it's going to be the same link, and these are here, these are all the weeks that we are going to be connected from 7 to pretty much 9:50. Okay, beginning today and then every week at the same time. So let's get into our weekly lesson. Okay, so something else that I'm going to be doing just for today's lesson, you are going to be able to see, we start here, you are going to be able to see that we had a bunch of PDF documents, but going forward, I'm going to be putting everything within Econestoga itself, and I'm going to try to break it in smaller chunks, just to see if that's going to make it easier to learn, okay? Because rather than having to go through a big chunk of information, I'm going to try to break the course into very small chunk of information so you don't get overwhelmed and you can master each individual chunk. And if you have questions from that specific topic, that way you can stop, and ask questions without having to worry. I still have to do all this other information in the same handout. So, but just for today, and still, I'm going to be putting, as soon as we finish talking, I'm going to be putting this information also in a web page format. You see that the instructional plan was a web page format. So I'm going to be doing the same thing for all the information that is on PDF. Okay, so when we come to the weekly lesson, which is one of the tabs, you are going to have this organized also week by week. Okay, so let me do something quickly here. Before I forget, I just want to do something live here. I just want to make sure that I write down the date just to make it easier, more clear. Okay, perfect. So I'm going to be doing that for all the different weeks, because that way, sometimes we tend to lose the concept of time, and we don't really know in which we are, but we always know which day it is. So that way you are going to be able to see where is it that you are supposed to be as well. So you are going to have that information from two sources, from the instructional plan, which is right there, and also from the weekly lesson tab that you have right there. Okay, so the first component in today's course, I want you to notice that you have two handouts here. Handout number one is talking about like scientific notation and metric prefix. And you can see that handout number one also have another handout right at the bottom that is called handout key. So all these different handouts that I will be giving you, you will have an answer key, just to make your life easier, and just to make sure that as you are solving all these problems, all these mathematical equations and problems, that you don't have to walk in the dark. You can go and solve them, like say 2 or 3 of them, and go back and check on the answer key to see if you are on the right track. Okay, so that's going to be the dynamic when you are working on your own. So let's begin here. Okay, so let's begin here. So here we have what we are going to do in today's class. Okay, so we are going to do like 50 minutes of class, just like if we were in the classroom. We're not going to change the dynamic. We are going to do 50 minutes, so from 7 to 7:50, and then at 7:50, I'm going to let you go for 10 minutes, relax, drink water, do whatever you need to do. And then we are going to come back at 8, and from 8 to 8:50, we are going to have another 50 minutes. And then from 8:50 to 9, you are going to be free. again. And then we are going to do our third portion of the class from 9 to 9:50. And then we are going to be, we are going to go to on our own until next week. Okay, until next Monday. So one of the things that we have to know well, okay, so I'm going to be shutting down my video while I'm explaining this because I want you to be able to focus specifically on the information that we are sharing. Okay, so the first component in DC fundamentals is to be able to go back into all these basic mathematical concepts. Okay, so in the electrical industry, we don't tend to say that, for example, like if you are looking at your hydro bill, you are going to see that they don't charge you by watts, they charge you by kilowatts. Okay, meaning that the amount of do anybody knows what is the price right now, today, January 25th, 2021? Do you know what is the rate for hydro right now in the province? The kilowatt hour?
Isn't it like 12 something? 12
Yeah.
cents kilowatt?
Yeah, like 12.7 cents, right?
Yep.
Yeah, so that's the rate. So what does that mean? That means that all your electrical equipment, whenever it's using like 1 kilowatt, if it uses 1 kilowatt of energy, that means that you are going to pay 12.7 cents for that kilowatt of energy that you have used. Okay, mostly we don't use too much, but I'm just bringing that up because I want you to be able to see that, in the electrical industry, this is what we use. We are going to use what is called engineering notation, okay? So I want you today, please, to slowly take the time and get into reading all this different information. Even when I'm going to explain some of it, we're not gonna have time to go through every individual item. So we are just gonna touch each individual topic. And once we do that, then you are gonna be on your own to go back to this handout and read the whole thing, because it would be like counterproductive if I start reading like each individual line. Like, what would be the point? You can do that on your own. I don't have to do that for you. Okay, so you are going to see that in electronics, you are going to use a lot of like milli and pico and nano. Okay, so in electronics, usually, even in level 1 electronics, you have to see like this terminology a lot, like milliamps. So if you have, for example, if you have 1 as the unit, and then if you have 0.1 M, you don't say that you have 0.1 M, okay? That's not what we say. So you then say that we have 0.1 M. No, we are going to say that we have, okay, so we are going to take this little dot, and we are going to skip that little dot 1, 2, and 3 spaces to the right, and we are going to say that we have, and then we are going to fill in the blank, okay? 1, 2, and 3. So, and then we are going to fill in the blank with 2 zeros. So we are going to say in that case that we have, oh, my eraser is going somewhere else, 100 MA, milliamps. You're going to see that a lot, okay? Anyways, let's get moving. So in the electrical field, sometimes we use like very, very large quantities. Like, for example, look at this quantity that we have in here. Can any of you please read this huge number for me?
That's 6.25 heptillion.
Yeah. But not many people would know that quantity. So, but that's a very, very large number. And even if you say that you have such a large sum, that would be very, very difficult, okay, to fathom. So in this instance, we just take our decimal point and then we move it a few spaces to the left. And then in this instance, we would say, like, let's move the decimal point 1, 2, 3, 4, 5, 6 is 6.25. Okay. Times 10. So how many spaces do we have to move the decimal point to get 6.25?
5.
Okay, so we move the decimal point originally is right here. So and then we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
19.
11, 12,
18.
13, 14, 15, 17, 18 from
18.
here to here.
Yep.
So if we move the decimal point 18 spaces, then we will be writing this number, as a scientific notation number, okay? So we would say that we have 6.25 times 10 to the 18. And what is that super large number? That is 1 coulomb. 1 coulomb is the amount of charge that you need in order to, in order to push 1 amp through a conductor. Whenever you have 6.25 times 10 to the 18 electrons together, you have 1 coulomb, and when 1 coulomb of energy passes through a point because it's being forced by the potential energy of 1 volt to pass through a point in a wire, then you have 1 amp. But that's a very, very large number. So that's why that we used scientific notation in this instance in order to express such a large quantity. Okay, so let's keep moving. So we'll be getting today into powers of 10 and also engineering notation, and then we are going to start doing some simple calculation. Okay, some simple, like transposing of formulas, which is pretty much one of the most important concepts today. Okay, so something important when it comes, I'm just going to highlight the most important aspect when it comes to powers of 10. I want you to look in this handout, for example. Okay, like let's say that we have this quantity, 25,000. 25,000 becomes pretty much 25 times 1,000. So 1,000 means that we have, okay, that we have pretty much like we are multiplying our 25 times 1,000. So 1,000 means that we have 10 to the 3. Okay, so 10 to the power of 3. So we are going to be using this number 3 exponent just to signify that we have pretty much 1,000. Now, it is important to know, and it is important to see, okay, let me erase all this here. It is important to know, and it's important to see like this other table here that we have right here at the bottom. So whenever we say that we have 10 to the 6th, we have the number 10 with to the 6th to the exponent 6 means that we have a million. 10 to the 6 is a million, 10 to the 5, 100,000, and so on and so forth. So with that in mind, whenever we are given any quantity, like 5 million, all we have to do is to say, well, 5 millions, you already can see this explanation here. So you take the 5 million and you take the decimal point for the 5 million, and then you skip that decimal point, which is right there. You skip it to the left in that direction until you go right in front of the first significant digit. That's important to remember. Okay, so when we are doing scientific notation, we're going to be moving our point always to the very first, okay, significant digit in front of it. So when it comes to powers of 10, though, okay, so there's a difference between powers of 10 and scientific notation. When it comes to powers of 10, it doesn't really matter where you will move in the number 2. So let me give you a little example of that. Let's say that I have this number, which is like 5 millions, and I just want to apply powers of 10. So in my solution, I have two different options. So if my solution was that I skip my decimal point, 6 spaces, 1, 2, and 3, okay, plus 1, 2, and 3. If I skip my decimal point, 6 spaces to the left, okay, so now I'm going to write the expression as 5 times 10 to the 6th. Now, this expression here, it is the way we write it down when we are expressing something in scientific notation. If I were going to do only a power of 10, what really matters, like this is just a combination of my power of 10 plus my scientific notation. So let's say that I have another number. Let's say that I have a number which is 250,000. And I ask you, okay, so can you write that number in a power of 10? So in that instance, like if I decided to write that I have 25 times, how many spaces do I have to skip my decimal point to get to 25? Well, 1, 2, 3, and 4, right? So then I say that I have 25 times 10. 25 times 10 to the 4. So that number is expressed as a number in as a power of 10. Now, if I ask you to write the same number but express that number as scientific notation, then you have to go one step further. In that instance, you have to take the little dot, the little decimal point, which is here, and move it all the way to the beginning. And now you have to express the quantity as 2.5 because this dot always has to be, let's say, like pretty much like right after the first significant digit. The decimal point is always written, is always placed right after the first significant digit. So in this case, for scientific notation, this becomes 2.5 times 10 to the 5. So what's the difference between the two? Yeah, you got a question?
Yeah, like so the 25 times 10 to the 4 is not considered scientific notation.
No, this is just a power of 10. So we just consider this a power of 10.
Right.
Okay, and this one at the bottom, then, this is proper scientific notation. So, and you may wonder, like, okay, so what's the point of doing that? The point of doing that is most of the stuff in the scientific community is done in scientific notation. That's why it has that name. So, but the point of doing that is just to remind you that in order, like the rule is that in order for any expression to be considered scientific notation, your decimal point has to be right after the first significant number, the first significant digit. In this case, my first significant digit is 2. So on the flip side, let's say that we have a very, very small number. Let's say that we have 0.0000254. Okay, what is that number? Let's say that that is amps. And now I want to express this, and okay, I'm not gonna get into the amps. Sorry, let me take that back because I don't want to jump into engineering notation yet. So, but let's write this number as a number in scientific notation. Do you want to give it a try to see what the number would be? So we got a decimal point right here. So what is that number?
All right, 1, 2, 3, 4. So 0.2. Is it the same side of that significant digit?
Perfect. Always right after the first significant digit. So yes. So you go 1,
2.5
1
times 10 to the power of -5.
5. Perfect. So then it would be 2.54. Okay. Times 10 to the what?
-5.
It's very important that we write that minus to the -5 because that minus indicates that we are going to be moving from from this decimal point. It means that it's going to be moving to the left. Okay? That -5 means it's going to be moving to the left. If that was a +5, and I'm going to put this in purple, when it's a plus, we don't never mark it. If that was a +5, it means that the decimal point is going to be moving in that direction to the right. So if that was 2.54 times 10 to the 5, then we would be moving that decimal point 5 spaces to the right. So we have a very large number. Now, if we have the minus, like in this instance, with the red color, if we have to the -5, that means that our decimal point is moving 5 spaces to the left. So anyways, guys, so I know that I said that we were going to do 50 minutes and then do a little break. So this is what I want you to do for your little break. Okay, so go ahead, please. And right here, okay, I want you to jump into this little exercise. You can take a break because what's the point if I give you an exercise rather than taking a break? But when we come from this 10 minutes break, I'm going to set the timer. Then we are going to get into writing numbers, powers of 10. I'm just going to be asking you live to do like 3 or 4 of these exercises, and also like writing numbers in decimal form and writing numbers in scientific notation. So we are going to get into this page, which is page number 10. Okay, so I'm going to be setting up the timer for 10 minutes. I'm going to be muting myself. And after the 10 minutes, we are going to be coming back to keep going with page number 10 in your handout. And if you think that we are going a little bit too fast through everything, I'm just trying to explain the basic concepts. and you still need to take the time to read the handout and to complete all these problems. Okay, so see you in 10. Okay, so we're bad guys. So let's keep going. So as I was telling you right before the small break that we had, now we are going to be getting into this little exercise where we are going to see the decimal form, scientific notation, and also power of 10. And we already like touched on power of 10. So, okay.
Are you going to go over the rounding?
Pardon me?
Are you going to go over the rounding?
Yes, but I want to touch on this, and then I'm just going to be like on the rounding. Usually that causes a little bit of confusion, so that's why I want to dedicate some additional time to that, okay? I want to cover like first, like your powers of 10, your everything else, and then we can get into the rounding, because that's a topic on its own, pretty much. And the rounding is not a big deal. It's just that, I mean, like everything is going to be rounded off pretty much to 3 significant digits. But we'll be getting into that in just a bit, okay? So let's get moving, guys. So in this instance, if we have, okay, so like if you go to page number 10, which is the one that I am showing you right now on the screen, I'm going to try to see if this gets a little bit bigger on your screen as well. So you can see that, well, I want you please just to take the time, take a minute, and write exercise, okay, so problem, let's say A, F, and let's say J, and N as powers of 10. How would you do that? Can you please go and give it a try to see if you got it? Okay, so it's just suffice. Yeah, perfect. Somebody wrote down, got it. That suffices. So if I'm going to be expecting you either tell me, like, I'm going to give you a minute, you either tell me, yes, I got it. No, I don't get it yet. Please let me know, because it's very important that we have this communication. Perfect. All good. Got it. Perfect. Thank you so much. So let's keep moving. It seems that everyone is on the same page when it comes to these powers of 10. So let's just go back, not go back, let's go forward into writing the following numbers in decimal form. Like if we have a number like this, let's say 10 to the 3, this is a power of 10. So we got to write this number as a simple expression, as a simple decimal form number. So in that case, 10 to the 3 is going to be what?
1,000.
1,000, perfect. And how do we know that? Well, we saw the table before. That means that 10 to the 3 means that we have 3 zeros, okay? Perfect. It is 1,000. So because you already know this, and if we have like 10 to the minus 5, then how many zeros do we have? Right here, like in exercise K, in this instance, like K, if we have 10 to the minus 5, we have what? 0 point what?
0.0001.
Beautiful. Absolutely right. Sorry. Okay, absolutely right. So we will have like point, like we will have like 0.00001. Okay, and that's going to be the answer. Any question on why is it that we are going to have the 0 and then 0.00001? No, we're good. Okay, so let's get moving. However, when it comes to these ones, this make it a little bit more clear, because in this case, we have a definite place where we have our decimal point. Like in this case, like let's say, like if I ask you to write down in decimal form this number, which is 7.31 times 10 to the 5, this would be rather easy, because all you have to do is to take this number and skip the number to the right 5 spaces. So we are going to be using this exponent, or this exponent is going to indicate how many times we have to skip our decimal point to the right. So we have our 7.31. So we are going to skip that number, that dot, excuse me, 1, 2, 3, 4, 5. And then we are going to stop right there. You can see that on this space, we have 3 on this blank space. Well, it's not a blank space because we have a number 3, and here we have a number 1. But on the other spaces where we don't have any numbers, then we fill the space with the zeros. So that would means that 7.31 times 10 to the 5 is equal to 731,000. Okay, 700, that's a comma, just in case, so you don't get confused. So that would be 731,000, right? Okay, so now for just a little practice, so I can make sure that we are on the right track here, I want you please to write in decimal form the following numbers, like, okay, like exercise N, exercise P, and exercise also like H. Okay, so I ask you for those ones. H and then P. So I'll give you a minute. Perfect. It seems that everyone got it. So let's keep moving then. Glad to see that everyone's got it. So let's get moving now. May we? Like the third exercise, then, he asks you for the right numbers in scientific notation. So remember once more that in order to write these expressions as scientific notation, we have to make sure that the decimal point is going to be right after, okay, or in front here of the first significant digit. So if I were going to write to answer A, that would be equal to 4.38. Okay, and because I skipped my decimal point from here to being right in front of the first significant digit, because I skipped my decimal point 2 spaces, then I have like 4.38 times 10 to the 2. Remember once more that these 2 indicates how many times I was skipping my decimal point, or how many times I need to skip my decimal point in order to get back the number to decimal form. Okay, so now I'm going to be asking you like to do the following problems, okay, just so you can check. Like do problem D, F. I'm going to be asking you for 4 on the G and K. So go ahead, guys, give it a try to see. Okay, perfect. So it seems that we are on the right track so far. Now that we have covered like this, let's jump into metric prefixes. Okay, so first, in order to do metric conversions, it's very important that we understand all the different prefixes, the prefix that we have for all these different like metric conversions, okay? And all this is based on what is called engineering notation. Okay. So in this instance, you can see like in the example that we have, we are right now in page number 11. Okay. So if we have 270 kilovolts, the kilo stands for 3 zeros. When it comes to engineering notation, we are going to always jump in steps of 3. Okay, so In this instance, the prefix kilo means 1,000 times a unit. So if we have 220 kilovolts, it means that we have 220,000 volts. Every time that we have the K, it means that we are going to be adding to whichever numbers that we have there. We are going to substitute that K for 3 zeros. Okay, so but let's say, for example, that let's say that we have 2.2 on the other hand, and I say that we have 2.2 kilovolts. So does that mean that I'm going to be adding 3 zeros because I'm going to substitute my K for 3 zeros? Well, you can see that here, right after the first significant digit, we have a decimal point. So that means that this K is like a 10 to the 3. This little dot will be skipped 3 spaces to the right, in order to be able to get our unit. So in this instance, instead of saying that we have 2.2 kilovolts, we would be saying that we delete this dot from here, and then we fill in the gaps with zeros, okay? 1 gap here, 1 zero here, 1 gap there, 1 zero there. So in this instance, we have 2,200 or 2,200 volts or 2,200 volts. Okay. So it is important that you get into a table. Okay, let me get back. Right here, that's page number 6. If we go back to page number 6, and you may wonder why this jump, like we were in page 11 and suddenly you take us back to page 6, is because page 11 is already like all the problems that we are supposed to be solving after reading the whole chapter or after reading the handout. So, and this is where we find the explanation to all these different concepts. So we have that, we have the engineering unit, Ideltera, Giga, Mega, Kilo. I got a quick question. I always like to add this question to my students. Do you use like a smartphone, a computer on a daily basis? Do any of you use cell phone on a daily basis? Yeah, you do? Yeah, you do?
Yeah.
Okay, okay. How many of you have like an iPhone? Like who has an iPhone? Let's say.
I got an iPhone.
You got an iPhone. Okay, so how many, I mean, what is the capacity of the memory in your iPhone?
128 gigabyte.
120, yeah, perfect. Somebody has 32 gigs. Somebody have like 120 gigs, 128 gigs.
I don't know what mine is.
Pardon me?
I don't know what mine is, to be honest.
Oh, you don't know yours. Okay. So like nowadays you see that, I mean, whenever you go to buy a telephone, you either have like right now, I think the minimum is like 128 gigabyte of 128 gigabyte of memory. And also like they get you into knowing like the RAM memory of the telephone, like if some of them is like 6, 8 or 12 or 16. And even if you have a computer, now we are using like whatever. Do any of you is using a computer?
Yeah.
Yeah. So do any of you use like a solid state drive or maybe just a normal like hard drive? I don't know.
I use both.
Solid
I know that SSD
Both.
action.
So what about in the case of the solid state? What is one of the most popular like memory capacity that you have seen in solid state drive? 1 terabyte. Perfect. So right there,
500 gigs.
yeah, right there, we already like just by talking about these gadgets, talking about technology, we just come to knowing, like, for example, we have 1 terabyte.
Mm-hmm.
Like 1 terabyte, like myself, that's what I have in my computer. I have a small like chip
Mm-hmm.
that is called, well, it's a small chip. I don't want to get into all this technological stuff, but it's 1 terabyte. But nowadays you can buy like whatever, like hard drives that are like 4 terabytes, 12, and whatnot.
Mm-hmm.
And what does that mean? Okay. You have to study a little bit of computing and know that 1 bit is a 1 or a 0, that is 1 bit. And then when you have 1 byte, you have 8 digits, and then it goes all from there. But the point is that in order to be able to talk about the capacity of all these devices, of all this technology that we are using nowadays, we have to use engineering notation. So when I say that I have 1 terabyte, that means that I have pretty much, this would be like, I mean, from the British point of view, this is 1 billion bytes of information. Okay, so when we like say that we have 1 gigabyte, like before 500 gigabytes used to be like a huge deal. Nowadays, 500 gigabytes is pretty much not much. It's not useless, but it's not much to have in a computer. It's not very attractive anymore. And in the case of in the electrical field, we are going to listen very often to quantities like mega and kilo. Okay, like for example, a power plant, how many megawatts, like an electric hydro plant, like a hydro plant can produce. Like maybe something is rated for 1 megawatts or 2.2 megawatts or 10 megawatts. And this is usually it's going to be telling you, instead of saying that, okay, this power plant or this hydroelectric station can produce 10 million watts, it's going to tell you it produces 10 megawatts. So we're going to be using, when it comes to science, we're going to be using engineering units all the time. We are stuck with it. And when you go in level 1 electronics, as I mentioned right at the beginning of this lesson, you are going to be talking about milliamps and microfarads and nanofarads and sometimes to picofarads. And you are going to be talking about like microohms, well, not really microohms, like milliohms, and also like millihenries, okay? Because we are gonna use all this engineering stuff, so we can be more specific and avoid the use of so many numbers, you know, so many zeros. Now, when it comes to engineering notation, you can notice like right here, what it says the symbol is just a letter, okay? Volterra, which is 10 to the 12th. Volterra, which is 10 to the 12th, is going to be a T, and you can read it yourself. Giga is going to be, which is like 10 to the 9. Then it's going to be like a G. Mega, okay? It's going to be like a million, it's 10 to the 6, and so on and so forth, okay? You can notice here that for kilo is lowercase, because there's no any other symbol that is going to have a K for any other letter. Like, for example, here, if I were using a lowercase for mega, then how would I distinguish the M for mega from the M from milli? Okay, so that's why that when we have them, all these other units, which are the small units, then we have them in lowercase, like milli, that is the letter mu, which is a Greek letter. Then we have the N for nano, and then we have the P for pico. And the base unit is always 1. Now, that being said, now we can start learning, and that being said, and being able to see this table from this table point of view, then we can start learning the difference between, the difference between, like when we have to convert from the unit into big numbers or from the unit into a small numbers. Let me give you an example. Let's say that we have just one watt. I'm going to say that we have 1 volt. Okay, just 1 volt, nothing more than that. Now, for 1 volt, we don't really have to do any conversion, but we'll just do a conversion for the sake of this class. Let's say that we want to convert 1 volt into into kilovolts. So in that instance, I have my 1 volt. So, okay, so that's my unit, 1 volt. So my decimal point, where is my decimal point? Right here. Is my decimal point on that side, or is my decimal point on that side? Where is my decimal point when I have the unit? Always, at all times.
To the right of the
To the right.
Yeah, perfect. To the right of the number. Beautiful. I like what you said there. So it's always to the right, because if my decimal point was to the left, then that would mean that I have 0.1, right? So we know that the decimal point is here. And if I want to convert into kilo, that number, that unit, then I have to skip my decimal point. Okay. Let me do this. Here. We are going from the unit to kilo. So this is 1 volt. So I'm going to be skipping. This is important. My decimal point, 1, 2, and 3 spaces to the left. Okay. So now I'm going to fill in the gaps with my zeros. So in other words, we have 0 point, and that zeros is pretty much meaningless. If you want, you can skip it and say just 0.001, or you can say, to be more proper, 0.001. Okay, so we have 0.001 watts. In this case, kilovolts. Beautiful. Thank you so much for saying that. Okay, so we have our kilovolts. Okay, so it's important. Do you notice that I was skipping when I wanted to go from the unit? When I wanted to go from my unit, in order to be able to express my kilovolts, I was skipping my decimal point to the left. Okay, but let's say now that we are going to be taking the same number, 1 volt, but now I want to express 1 volt that I have as millivolts. So in that instance, I'm going to be taking my decimal point, which is right here, and I'm going to skip it 1, 2, and 3 spaces to the right. Okay. So now that I'm here, right at the unit, when I want to express a small quantity, okay, when I want to convert, just keep that in mind, from the unit to a small quantity, then I got to skip my decimal point to the right. I'm going to be filling in the gaps with zeros. So we have 1, 2, and 3, which is 1,000. Then we have 1,000 millivolts. So if we are here, right at the unit, we got the unit here. When you are right at the unit, if you want to convert any number which is right at the unit to one of these large engineering units, then we have to skip the decimal point to the left. Okay, but if we want to convert the base unit to any of these numbers, or excuse me, to any of these units, which are the small units, then we got to skip the decimal point to the right. That being said, okay, so let me give you then a little exercise. So let's get back into page number 11. And I'll give you like just a small problem. I'm just gonna ask you to do just one. I just want you to do the first exercise, okay? So in this instance, we have 1,200 ohms, and you gotta convert it into kilo ohms. So what is the answer? Please type it. Perfect. Thank you so much. Absolutely right. So it's going to be 1.2 kilo ohms. Okay, so let's do another one here. But let's say now, like problem number 4, you have 47 kilo ohms and you got to convert it into ohms. So what is the answer? Okay, perfect. So just to be clear, guys. Okay. Okay, so just to be clear, so which is important, I can see that some of you write 47,000 with a comma, and some of you write 47,000 without a comma. The proper way to write the number is with the comma, okay? So whenever you are doing a test, please make sure that you are writing your commas. If you forgot to write it down, I'm not gonna mark the answer wrong, that's okay. But it's gonna make my life easier, unless you wanna make my life difficult. And if I find that that's the point, then I'm gonna mark it wrong. But the proper way to express any quantity is with the commas, because that's how you can divide that you have like 3 ciphers. So every 3 ciphers, then you got to put your comma, right? We know that from elementary school, but I know that because a lot of calculators, they don't really put the commas anymore. Like I have some applications where, yes, the calculator put the comma, and I have other calculators, well, the calculator doesn't add the comma. And that's why that there tends to be a little bit of confusion on what is the right way to do that. However, even the calculators, sometimes they just, instead of putting a comma, they give you a space in between. So they would do like 47 and then a space and then 3 zeros. But when we are doing that in paper, because we don't want to make mistakes, we got to make sure we put those commas, okay? Just giving you the heads up. So it's, okay, so let's get moving. So in the next problem, I just want to see like, okay, so problem number 10. Can you please go ahead and do it to see if you're good there? Perfect. Okay, perfect. It seems that somebody's asking where's the ohm symbol. What do you mean by that, Mr. Weaver?
I think they're just talking about on their computer.
Yeah, I just saw your boy. Hold on, let me get a name here.
Oh, okay. Yeah, I see that.
He
You
threw
were
in
wondering if on the test you have to write down the symbols.
Option Z.
Well, don't worry, guys. When it comes to the symbols in the test, or whenever you are doing any work, let's say, you would have to learn all these alt symbols. Like, for example, ohms is alt 234. But to avoid that hassle, and whenever you are doing a test, I don't ask you to write symbols. I just ask you for the numbers, nothing else. So let's say, like, if you are writing a test and you have, and that's how you are going to see it, and you have like an space where you have to provide an answer, I'm not going to be asking you to, like, for an answer like that, to write like that you have your 270 ohms. As long as you write 270, 270, you're good. That's it. Kind of makes sense what I'm saying here?
Yep.
Okay,
Gotcha.
perfect. Now, if you happen to write the symbols, still I'll mark it right, as long as the numbers are right. Just give me 1 second here. Okay, so the next problem, and this is going to be the last one before we move on, that I want you to do. Okay, so let me check this one, number 16.
Oh shoot. The ohms. Oh, that's good.
Okay, perfect. So that's what it is, 24,600 volts. Okay, let's keep moving then. So somebody was asking me, like, that for the rounding off to 3 significant digits. So let's cover that now. Okay. And that way, when we come back from the break, after we come back from the break, then what we are going to do is that we are going to focus on small equations. Okay. Thank you so much. It seems that we are on the right pace here. Okay, so it's very important, okay, when it comes to significant digits, it's very important that you take the time to read through the information, okay? So most practical calculations is gonna tell you I'll limit it to only 3 significant digits. So in this instance, you are getting an example here. Let's say that a friend of yours, he says that he tells you that the speed of his car is clocking at 104.6784935 miles an hour. Okay, so we know that whatever, like a radar, is not going to be reading like all these small numbers. It's just going to be rounding things off to the most important digits. Okay, so in this instance, you are not going to be getting like this 10-digit readout. And also electrical measurements. In electrical measurements, you're not going to be getting like those many readouts. Usually meters, they are limited to like 3, 4, or 5 digits max. And after that, because everything is rounded off. To say that we have like 105, let's say 105, 105.646 volts, a meter is not going to be reading that. An oscilloscope, which is a very expensive equipment, sure, it can do it. But for our regular everyday use meters, I mean, we are going to be using only pretty much 3 significant digits. So in this instance, like in the instance of, in the example that we have here in this handout, so instead of saying that we have 104.678 and all these digits, we could round everything off to 3 significant digits and just say that we have 105 miles. Okay, so the 3-digit accuracy is going to be enough to express the quantities that we want to express. Any questions about that? However, like there's sometimes a little bit of confusion because sometimes we have a lot of different numbers, and we have to make sure that, okay, so let me get back into this. Okay, so let's get back into here. Let's say that we have a different number, like for example, 0.000020543. Again, that's a big number. Okay, so in this instance, if we were going to express this, if we were going to round this off, pretty much we are going to round off to 3 significant digits once more, and then we are going to be dropping everything else. Okay, so in this case, if we have this 0 point whatever, we could pretty much, as you can see in the example here, get rid of the 43 and just round it off as 205. So we would say that we have 0.000205, and that will suffice. And now you may wonder, okay, so does that mean then that, okay, what you were learning at school, like anything which is below 5 get chopped off, and anything which is above 5 go to the next digit? And that's exactly what we are going to be doing here. Let's say that in this example, instead of having the 20543, we instead has 205, let's say 53. I'm going to delete the 4, and I'm going to say that we have 20553. So in that instance, instead of saying that when we round it off, instead of saying that we have 205, we are just going to say that we have 206. Okay, so you can see that we are going to be writing still these numbers the same way, 20, and then this 5, okay, because this number is going to be rounded up. Okay, so we are going to pretty much like increase this number to the next significant digit. So in this case, we have pretty much 55, and this 55 that is right beside it, it's going to become 6, 0, pretty much. But because we don't have to mark the 0, it's just going to become 6. And we are going to say that we have 206. So what do you mean capping? Yeah, we are going to cap everything at 3 significant digits. No more, only 3.
I'm just playing.
Pardon me?
I'm just making a joke. Like, I'm just being an idiot. Don't worry about it.
Okay.
Like, are you lying? Like, is this actually the hardest thing? Yeah.
I don't want to make a big deal out of it. Okay, so let's get into the exercise. Okay, so let's get into rounding off. So please take the time and read the rationale behind it. I didn't want to spend the time like reading you the rationale. I just wanted to give you a practical example. And let's get into this one here. Okay, so we're going to be rounding off these numbers. Let's say that we have our first one, 746.23. Remember that we are going to be rounding everything off to 3 significant digits only. Okay, if there's any discrepancy with the answer key, then I'm going to be fixing that answer key. But I'll check that there's no any. Okay, so we have, like in this instance, 746, and we have to round it off. Because our, after the point, we have just 23. Okay, in other words, we only have 0.23. We can get rid once and for all of this. So when we round it off, we are going to say that we have 746. That's it. Okay, now when we have a number like this, like in the second example, again, we are going to be rounding off to 3 significant digits. So in this instance, the we have like 506. Those are the 3 significant digits. After the 3 significant digits, because the next 2 digits are below 5, we just get rid of them. So when we round it off, we say that we have 0.00506. So in this instance, though, because we are using only 3 significant digits, remember that. So we have like 84,896. Okay. So still my 84,000, I have to write my 84,000. I cannot get rid of that number. Okay. So sometimes people feel tempted just to write 85,000. But if you want to be completely accurate, in reality, because I'm going to be using my 3 digits, I can write this expression as 900, 84,900.
Mr. Garcia?
Yes, sir.
Are we safely assuming that for all tests, we're just going to go to 3 significant digits the entire time?
Yes, that is correct.
Okay.
Now, let me tell you something. When you are doing, and I'm going to tell you that so you don't get confused, I mean, in the future, when we are doing calculations, let's say with circuits, when you write the answers, you can do your 3 significant digits. That's not a problem. That's perfectly good. Now, when you do the actual calculations, like if the calculator give you, like, let's say, a number like this, okay? So just save it to the memory and use all the numbers so you can get that 3 significant digits accurately. Kind of makes sense when I say
keep all your numbers until you have your final answer.
Perfect. So you are going to use your significant digits for the final answer. But for the calculation itself, don't round it off to calculate. Round it off only to express or to give me a final answer. Kind of make sense?
Because what I'm thinking is you take your number 84,000 and you're going to round that 8 up, right? So 849, let's say. And then you have the 2 and you just ditch the last ones. Are they zeros, or does that make sense?
Oh, yeah. So it would be 84,900, right?
Yeah.
Okay.
So, but when you are doing the actual calculation,
You wouldn't.
because you are rounding things off, I mean, that's only to express an answer. It's not to do the actual calculation, like using the calculator, because that's going to throw you off, of course.
So rounding is only like once you've already calculated everything. This is
Perfect.
my answer.
Because when you take a meter, let's say, and you measure your RMS, or you measure a socket, you measure a plot, right? And you take a meter and you stick the leads on the plot, it's just gonna give you like a 3-digit number. Sometimes it's gonna tell you it's 124.5 or 124 point or 120.7. It doesn't matter what it tells you. But that's just the final outcome. That's the final score, pretty much, for that plot. But if you took an oscilloscope, on the other hand, and you measure the same quantity, it's going to give you everything. So what I'm saying here, like if I were going to do a calculation for calculation purpose, I would be using the one from my oscilloscope because it gives me the whole spectrum. But just to get the final answer from something, I'm gonna be good with 3 significant digits, and that's gonna be more than enough. So that being said, because I want this to be very, I want you to be very clear on this. Let's say that you get an answer in any calculation, okay, that it gave you 746.23 volts. Listen, just write 746. That's more than enough. The 0.23 volts, it's not going to do anything for me or you.
Now, if we forget to do that, would you take marks off?
Of course not.
It's just those main important numbers.
Okay, it's just to make your life easier. That's the point. So I want you to do something, like I want you to take the time, like, okay, let's do something right now. We are almost due for a little break, and we'll take it at 9 in 3 minutes, and then we'll do the class from whatever, like 9:10 until we finish at 10, okay? Do you have another class after this today?
Yeah.
Yeah, we have one right after.
Right at 10?
Yeah, absolutely.
Yeah.
We have prints.
Okay, so then what I'm gonna do, let's start the break now. And then that way you can have a little bit of whatever, wiggle room before you start the next Zoom meeting, okay?
Sweet.
So I'll just give you like this time, like 5 minutes only. And that way we don't steal any time from class. Can it make sense? It's okay, are you okay with that?
Yeah, that sounds good.
Yeah.
Yeah, that works.
Okay, perfect. Okay, see you in 5. Okay, guys, so let's get back. Okay, so now, okay, so I'm back with you now. So we are going to get into, as I said before, we are going to be getting into transposing some equations. And then, as I promised, I'm going to be recording a video this week about the electrons, you know, like electrons, the basic theory on that PowerPoint. So please keep in mind that going forward, I will be asking you, I know that we already, during this class, we took the time and we did a few problems. Take the time and please practice a little bit more, okay? You don't have to do each single one of them. I mean, the reason why you have so many is because you are going to be able to skim through it and you are going to be able to mentally do a few of them pretty quickly, but some of them are going to challenge you probably. And those are the ones that I want you to focus upon, not on the easy ones, but on the ones that could pose a challenge. Okay. So as long as you do a few, like 3, 4, 5, 10, whatever you want, it's completely up to you. So once we finish this class, please make sure that beginning like in the achievement review, beginning in page number 9 of this handout, that you go through the whole handout, okay? And you will start solving some of these problems. Now, before we move ahead, I'm just going to be asking you like once more, okay? So I'm just going to throw you one little problem here to see how you come out. I want you please to make this conversion, 3.2 milliamps to amps. Please go ahead and do it. .2 milliamps to amps, please. Go ahead. Perfect. Thank you so much for being so responsive. That's great. Perfect. That's good. Okay, so let's get moving. Now let's get into transposing equations. Okay, so you are going to have the time and complete all this in your own time. So now we'll get into another handout. As I said before, okay, so let me take you back here. As I said before, you don't have to do each individual problem, okay? So as long as you feel confident that you know the concepts, that you know how to convert from the base unit to to the bit units, to kilo ohms and mega ohms, and to the small units like milliohms and millifarads or microfarads. As long as you feel confident with it, I'm good with it, okay? So I'm not going to be asking you to submit anything at this point in time. So, because it's your own work, okay? It's your own worth as well. So as long as you feel confident, it's perfect. And of course, if you happen to have any questions, then you let me know what questions you might have. Now we are going to be jumping into a different topic, which is transposing. Just bear with me a second. Okay, so okay, so on the first portion, this is just a little review on engineering units. Can you see my screen right now, or?
Yes, sir.
Yes, you can see it. Perfect.
Yeah.
Yep.
So I'm just trying to use my smartphone because I have a pen to make it easier and not to have such a sloppy.
Is it blurry for anyone else?
Fancy. Not for me.
No, I'm good.
No, it's good.
Yeah, it's good for me.
Good.
It's good now?
I have an ancient computer.
Oh, wow. Sorry. But maybe it's the internet connection. Maybe it's not fast enough.
All good. I'll figure it out.
Was it blurry before?
For me, it wasn't.
It's all good. I'll be able to manage.
Oh, okay. So anyways, this is being recorded. So once I, like process the recording, then I'm gonna be posting that on the recordings on Nikonestoga as well, just in case you wanna revisit any topic at all. Okay, so in this instance, we are gonna be getting into transposing. When it comes to transposing, the thing to keep in mind is that let's see. So when we have anything which is adding, let's say if we have A plus B, which is equal to C, and we want to be able to transpose C, which is a variable, I mean, we can assign any number to that if we want, then anything which is adding, okay, so let's say that we want to transpose A. Anything which is adding is going to go to the other side of the equals sign, performing the inverse operation. Let's give numbers to this. Let's say that C is equal to 10. Okay? And let's say that B is equal to 3. So in this instance, the number that we don't know is A. And of course, by simple inspection, a lot of you already know the answer. But for practical purpose, we have to be able to transpose the equation. So in this instance, we don't know the variable A. And you can see that A here, it is adding. So A, in order to find A, we have to isolate A. Then we are going to rewrite the equation, and we are going to say that A is equal to C. Okay, this B, it is adding, so it's going to go to the other side of the equals sign, performing the inverse operation. Okay, so it's adding, so it will go to the other side, subtracting. Now we are going to have that C minus B is equal to A. In other words, 10 minus 3 is equal to 7, and 7 would be the answer for A. Is that clear? Or does
Yep.
yep, clear? Perfect.
Yep.
So now if we keep moving, then we have, let's do the opposite, okay? Let's say now that we have A plus minus B. Instead of plus, now we have minus. So I'm gonna keep this the same. A minus B is equal to C, right? Still, we are gonna list the same numbers. And now that we change the symbol to minus, we want to transpose this formula. Now we have, it's going to be the same transposing, but now again, we're going to be isolating A, and we are going to say that A is equal, okay, so we have the equal signs here. So B is subtracting, so it will go to the other side of the equal sign, performing the inverse operation. It's going to be equal to C plus B. So that being the case, then we are going to have that 10 plus 3 is equal to 13. And of course, when we substitute the number that we found, okay, so that is A equal to 13. So if we substitute into the original formula, we have the 30 minus 10. Okay, sorry, 30 minus 3, which is B, is equal to 10. That was the answer for C. Are we okay? Are we still good there? Or do you have any questions about that?
Yeah, we're good.
We're all good?
Yeah, good.
Okay, so now let's continue to use the very, very same problem. But now we are going to change the symbol from minus to times. I'm going to modify this a little bit here, okay? And we are going to have that A times B A times B is equal to C. I'm going to say that C is equal to 30. And I'm going to say that B is equal to 3, for simplicity's sake, okay? In this instance, then, this X or this times sign, in order to transpose it, is going to go to the other side of the equal sign, performing the inverse operation. The inverse of multiplying, do you know what it is?
Dividing.
Dividing. So we are going to have that A is equal to B, okay, divided by C. So that being said, when we perform the, excuse me, sorry, let me take that back. Okay, just the little typo. So C is not going to disappear, sorry. So A is going to be equal to C divided by B.
Mm-hmm. Yeah.
So when we substitute the variables by the numbers, so we have then 30 divided by 3, and that will give us a 10 for A. So A is equal to 10. So if I want to prove if my transposing was right, then I would substitute into the original formula the number that I found, and then I would say, okay, is it really that 10, which is the number that I found for A, times 3, that is the number that I already have, 10 times 3 is equal to 30. So yes, everything matches. So that means that I was able to transpose my formula the right way. Now, on the flip side, if we use this fold division, okay, so I'm just going to use this. And let's say that instead of having the times, now we have that, okay. I'm going to change these numbers here so they can make sense. Otherwise, they wouldn't make any sense at all. I'm going to use 20. No. Yeah, sure. 20. And I'm going to use here 5. Okay. So in this instance, I still want to find A. Okay. So I'm going to say, well, if I want to find A divided by B is equal to C. So A is equal to C. So B is dividing. So it's going to go to the other side of the equals sign, performing the inverse operation. The inverse of dividing is multiplying. So my equation is going to become A is equal to C times B. So when I have C times B, C is 20, B is 5. So that's going to be equal to 100. So A would become 100. So when I substitute the number that I found into my original formula, okay, so now I have 100 divided by B, which is 5, is equal to the answer that was 20. So, and everything matches. So we know that the answer is good. So, and that's the basis for equations. That's the basis for transposing equations as well. Now, we are just missing 2 more. Okay, so let's finish with this. If we have an expression where we have an exponent, okay, we have an exponent. Let's say that we have the following. We have the A squared is equal to 25. Okay. So if I want to know what is the value of this variable, which is called a, whichever number that is a is going to be equal to a resultant, which is 25. So in that instance, I'm going to take my exponent, which is right here, and the exponent will travel to the other side of the equal sign, performing the inverse operation. The inverse operation of the exponent is, do you know what it is?
Square root.
A square root. Perfect. So this exponent will disappear, and then I'm going to have that 25. A square root of 25 is going to be equal to a, or a it's equal to the square root of 25, which in this instance is 5. So when I substitute this 5, okay, so I have that a is equal to 5. So when I substitute this into the original formula, then yes, indeed, 5 squared is equal to 25. So far, so good?
Yeah, we're minty fresh.
Yep.
Okay, so
I think we're good.
So we're good. Thank you so much. So, and then when, like if we have the opposite, where we have already like a square root, okay? So if we have the opposite scenario, I'm just making sure. I know you study all this in high school, but this is always the start on day one, you know, like in theory. So let's say that we have like, well, the same 25, whatever. Okay, okay, a square root. Let's put it like this. So a square root of a is going to be equal to 10. And then I want to be able to find out what is the variable that I have. If the square root of a is equal to 10, so what is the value of a? Well, we do the same thing that we have been doing so far. This square root expression is going to go to the other side of the equal sign, and then we are going to rewrite the whole expression as a is equal to a square root. We'll go to the other side of the equal sign as an exponent to 10 to the 2. Okay, so 10 squared, that means that a is going to be equal to 100. So that means that when we substitute the 100 into the original formula, then we have that the square root of 100 is equal to 10. And those are the four, like the 6 different, pretty much like the 6 different like expressions that will have to be able to transpose between them. Okay, so let's keep moving, my friends. And now, what I'm going to be asking you to do, I'm going to be asking you to take a couple. Okay, so I'm going to be, okay, first I'm going to give you one problem, and then I'm going to ask you to go through the handout and just choose one problem yourself. So let me, so let me get back so you can see it. This is what we are right now. So I'm going to ask you, please, to do the following problem. Okay, let's say this one, problem number 4. Go ahead, please, and solve it. 4k is equal to 68. So what's the meaning of k? How much is k worth?
17.
That's good. You got a singing voice. Perfect. So let's keep moving. Okay, what about problem number 13? Right here. What is the value for V? Probably you didn't even transpose it. You did it by simple inspection. That's good. That's great. Perfect. I can see that everyone is on the right track. Beautiful. Thank you. So I'm going to give you a couple more, and then I'm going to jump into a formula, okay? Perfect. Perfect. Thank you. So now let me give you, okay. It seems that we are on the right track here. Here, I'll give you this one. Okay, so number 8. Beautiful. Perfect. You got it right. Any questions?
I have a question. If we were to do question number 12,
Yeah.
would you prefer it as a fraction or as a decimal?
It's better to, I mean, like do everything as a decimal.
Just the 3 significant digits?
It's just because it's going to be more difficult for I mean, like it's going to be usually more difficult for you to try to type it as a fraction and to make it understand and to make it look good. So it's better just to express. I know some calculators give you the answer as a fraction, but write everything down as a decimal. But thanks for the question. Okay, so let's jump into something else. Yeah, it's the decimal nation. Okay, so let's jump into something else. So now I'm going to give you a formula in which we are going to be using Ohm's law. So we'll jump to that right away.